So today we will just discuss about big data analytics. So I'll just give you an overall introduction of big data analytics. If there's any doubt you have in between, kindly you can just interrupt and you can ask me also. Okay, so this is just an overall idea of what big data is and what is the difference that it makes when you have to do machine learning or analytics on big data. So why do we talk so much about big data? What are the characteristics of big data and also this is what I have arranged in a way. I just wanted to explain to you about what is a big data, what are the different characteristics of big data, what is this big data value chain goes by, and what technologies that we use for handling big data as of now, and what are the machine learning challenges. So you have learned a lot of machine learning techniques in these 2 days. How do we apply it for big data? What are the research trends and open issues? So some of you are doing your PhD and then your PG courses, so you may have to take up some research on that. So what are the open issues that are available? Where do we apply big data, or where we can see a big data? What are the risks of big data? Why should we really look into big data as an opportunity? Then what are the leading vendors available here, and what are the technologies, and what are the future of big data? What is the future of big data? So somewhere I've oriented the talk like this, where I can give a bird's eye view on all these aspects. Inviting many queries in the beginning, but still we've heard about this big data many times. We know that there is that means there is some data which is not big also. So what exactly is this big data? So if I ask for a trial, if any of you want to just say what is a big data, what qualifies some data as big data? When can I call some data as big data? Just to start with, I can't see the number of participants, but my scholar said that there are around 50-60 participants. So you want to say, is there any differentiation? So when we are qualifying it as big data, what is the difference? Is there any definition for that? Any of you want to just say something? Just checking, what type of participant. Yeah, very good. I've got 5 V's of data, ma'am. Very good. Any other answer? Some of you are typing it, na? That is also fine. Checking how, what group of participants you are. Typical online, or whether you will interact. Data which can be very large. Okay, so Shivananda, what is this data which can be very large? How do we quantify that? Very large means, say, how do you quantify? So can I say 10 GB, 1 TB? I'm just asking what is in your mind. You are whatever you say, your answer would be right. When will you think that the data is big? We've written it volume, variety, value, velocity, variety, all these characteristics if that data has, then we call it as big data. That is correct. Okay, that is correct. Then you said volume. Do you quantify that volume? You want to try quantifying that volume? I say this data is big. According to me, this much TB of data is big. Like that, any answer is there? Just a trial, and then I will continue. Some quantification of the data. 1 TB, 2 TB of data. Yes. 1 TB of data. Okay. So you said good answers that you have got. This is true. So when if you look into the definition, there is no single standard definition for it. Okay. If you look at Gartner's definition, people usually refer to their definition as one of a good definition. You can quantify you can define a big data, high volume, high velocity, high variety information assets that demands cost-effective, innovative forms of information processing. That is, you can't do the decision processing on your own. You need some extra tools for it, extra algorithms for it, and so many things you talk. So see, I would like to tell you, when you look at the bottom line, we cannot really quantify a big data as, say, if the data volume is above 1 petabyte, 1 terabyte, then I call it as big data. Okay, for us, maybe as an academician, So if you, as a student, if I ask you, I have 2 TB of data, just run an algorithm, a k-means algorithm, and classify and bring the data to me, or do clustering on it, it may be a difficult task for you. But if you look at a service provider, or if you look at some companies like Google, this 1-2 TB is every second it is being generated. So for them, it is not big data. So bottom line is, we can call this, that is according to volume. Similarly, velocity, the rate in which it comes, say I acquire, say 10 samples per minute, or per second, or per minute, then I may call, because I don't have the capacity to handle it at my end, I may call it as big data. But for another company or for another industry, that is not at all a challenge to handle, say 10 records, 10 samples, or 10 KB data per second or per, so that depends. So usually any data that exceeds our current capability of processing, we can call it as big. Okay, that is one definition. That is one bottom line which I would like to say. And when we say we cannot handle it with the current capability, means handling means you are not able to store it. You don't have a proper data structure to store it because of the variety that it has. You are not able to store it because of the volume that it has, because of the speed in which it is coming. You don't have different streaming tools to handle it and store it. That could be a reason. Then if I want to apply some machine learning, find out some pattern, I don't have proper algorithms to work on it. That could be a problem. So when I say I cannot handle it, I don't have the capacity to handle it, it means there are a lot of challenges in this big data. I don't have any 1 or 2 capability also. Maybe I have a storage solution of 1 petabyte, but then I'm not able to handle the velocity. I'm not able to do analytics because my data frame, the programming framework that I have is not supporting this distributed working. So all this is the meaning. Capability means you should not think that just because I don't have a storage space, I cannot say that I cannot handle big data. It is not only the storage. Okay, so that is what is given in the second thing. So scaling, diversity, complexity, new architecture, you need new algorithms. Every point, in the pipeline of this acquisition to visualization, you need a set of new tools and techniques to handle this data. So as you all rightly said, there are different V's, and yesterday one of my research scholars has given me around, I think, 12 V's of big data. There are a lot of V's that are emerging, but now initially there were only 3 V's, but now we can see that 7 or 8 V's are almost given here. So I just want to, for those of you are listening for the first time, you may be new to this. So there are 7 and some 8 V's. So I've taken both here. So we will start with volume. So you know what is the meaning of volume. If the volume of the data is so large that we cannot handle it at our end, as I said, there is no rule which says that above 10 TB is big data. But if you cannot handle the volume at your end, you can call it as a big data. Then comes the another important thing is the variety of it. So when I say variety, the different types of data, I used to ask every time in my talk, are you listening? I wish somebody can say yes or no in between, because otherwise, okay. So Swati, Anjali, okay, I've got few students whom I can, call. Okay. So now see, when I talk about variety, see, I am giving you, I used to tell this in most of the talks. See, it's a very simple, typical example I'm giving you. I want to find out what is the feedback of my talk, Okay. So after my 1 hour of session, I am allowing you people to, I'm not getting a formal feedback, but instead I'm telling you, you can discuss about my talk in WhatsApp. And then assume that I have access to all the data that you people are talking about. So you can just discuss, there are around 50, 55, 60 students, you interact among yourselves about my talk and assume that I have access to that data, whatever you people were talking about. And I understand that you were talking about only my talk. So I know that information is so vital to me. Suppose I am given access to that. Tell me what are the challenges that I will face, not a machine learning algorithm, manually, how the data will be. For me to analyze that data, how do I store the data? What will be the format of the data? How do I store it? And then how do I look into it? What will be the format of the data that you discuss? It's a social media data. It's a typical example of big data. And I know in 1 hour, so many, I will not be able to even count the number of messages that you have been exchanging. And there are maybe 60 students, so imagine 60 combinations of 60 messages. So that is, and the rate in which it comes in also is very fast. Okay, so first challenge is how do I store it? Any idea what will be the format of the file? where I can store this data? Some typing was there. Now nobody is doing anything. Just something you can type. CSV, good. Any other answer? One and two. Okay, it could be CSV. What will be the JSON objects? Very good. Then, okay, if it is like CSV, what would be the attributes that we store? Okay, if I have in your WhatsApp messages, you may have some trolls, you may have GIF files, you may have text, okay, and then you will have what else, images, whatever, not emojis, so many things. Some audio files may be there. You say some in your own language. You say that the class was very boring. So you will have a variety of data here, okay, and this also I will find it difficult to store this data, because at least if I know that it is text, I have a combination of text, numerical data, images, then I can store it in there. But sometimes I get the data which is totally unstructured. There is no particular format for it. So as you said, like a JSON object, I may use some semi-structured kind of an data structures like JSON, where I can use some XML tag. Like that, maybe I can store. That is one option. Still, that has limitations. So that is a variety of data that I get here. You understand? So that storing itself is a problem. Supposing I have stored it, then I have to eliminate certain things out of it. I want to find out the value. Okay, whether you people were talking about that only, or some other unwanted information was there. Next thing is the trustworthiness, veracity. Suppose somebody else has, they have not really sent some message, and someone else has sent some, you're doubtful to some message that is being generated there. How do I understand? That is the veracity of it. Now, after getting all that, speed, how fast you people type your, somebody speaking? I am not able to hear anything. Expand channel to show it. Okay, so that is another challenge. The velocity, how fast this in 60 minutes, how much of data I would have acquired. So these are all differences. Also, the data keeps changing because while conversation, it's a social media data. So you started with a negative feedback. Maybe it can end up with a positive feedback. So you say a sentiments can change. Apart from all this, assume that I have got this data. Do you think manually, if I look into this full bulk amount of data, will I be able to really find out what is there, even though me being a human being with all common sense, all intelligence, if I look at it, your language in which you have sent would be half English, half your regional language. And you may have your own code of sending a scroll, which I will not even understand sometimes. So as a human, I find it difficult to analyze the data. I have a proper good NLP system, which looking at a given text, we can analyze the text and say whether it is a positive polarity or a negative polarity. In that case, which NLP algorithm will I use for this particular text that I have gathered? Assuming that I have left out all the other type of data, only the text. Even the text is not going to be English, or it is not going to be any proper regional language also. It will be half English, half proper language, half colloquial language, half emojis. So that is actually the. Now this is just a simple thing that I wanted you to tell me about the feedback of meta. Suppose if it was a vital information or a sensitive information, even a terrorist is going to tell us that, okay, they are going to plan for an attack in this particular city, in this particular time. And they will say, we will discuss all this plan, all this in social media. What will we do? How do we analyze? Earlier, in Twin Tower attack 2002, we spoke about this technography. And then they were discussing, all these messages were sent, and the information was hidden in an image. And then those kind of techniques came up that time, which became very prominent after the attack. But in this case, what will happen? So that is the vulnerability that we are in right now. This is the challenge of big data. So this happens every time, but this is being addressed. So you know that if a new product is launched or a new film is launched, people are taking comments from the users. They are looking into the social media data, and then they have algorithms which are instantaneously finding out what is the feedback or what is the opinion, everything. And then based on that, the recommendations also change. So all this is also being happening. So it is not a big, it is a challenge, but it is also being addressed. So this is one idea about big data. So in this case, we can call the data which you as social media data, which I have given as a typical example of 7 Bs. And this I found more interesting. There are two more parameters which are not available here, which is given here. 1 minute. So what are those two? Can you just name? In 7 V's, I have shown you few V's, and here 2 more V's are there. What are they? And do you want me to explain on that? Very good. Viscosity and which is the other one? I'm not showing you the previous slide. Virality. Very good. Okay. This is Dr. Judy and we joined the meeting. I'm audible, then I can at least find out. Very good. Okay, so you have written virality and viscosity. This is another 2 V's which are coming in now for the students who are trying to do research. You can see that this virality is viral information. We say the information is very viral. So how quickly this information gets dispersed across people-to-people networks usually. Okay, and it measures how quickly the data is spread and shared to each unique code. So if an information is just gone, how fast it is. So what is the determinant factor you take here is the time, or you can also look at the rate of spread, how fast it is being spread. So that is another important factor which is qualifying big data. And viscosity is because you know that the data is generated from different different sources. Okay, so how do we actually look into it? So this actually measures the resistance to flow in the volume of data. So this resistance actually, as I said, it can come from different sources. Maybe some friction is there from the integration and flow rates, or it is how much time you need to process this data to turn it into an insight. So does it call for an action? Should I look at it properly? Is there all this is actually viscosity. The resistance to flow in the volume of data, you call it as viscosity. So these are other ways which are qualifying big data. I think this much is clear. Now I just want you to know a few things about the volume that we were, some these which I have explained a little more in detail. So see, this is I think all of you know this. We are talking about, as I said, for a student, as I said, 1 TB data may be higher, then it goes to petabyte of data, exascale. Current supercomputers, they can perform up to exascale performance is there. But there is something now, the current in 2020, if you look at it, we have the digital universe has around petabyte of data. That is what is given by a statistics. I think few more slides are coming on that. And then it may once reach up to this Bronto byte. That is what they say. This is the highest as of now, 10 power 27. So this is how the data, it is an exponential growth of data that is happening day to day. Okay, so this is okay. And to look at the importance of it, you can see that this one typical slide I keep is an older slide, but you can see for a student who is new to this, when I talk about a petabyte of data, okay, a petabyte, when it is if you have a DVD, 55 stories of DVD. So you have DVDs. I don't know how many of you have even seen DVDs nowadays, but if you have a DVD, a music, suppose you have a film stored on that, you file up this DVD, it goes up to 55 stories, then I call it as a 1 petabyte. So if you're trying to, measure it like this, that is the quantity of a 1 petabyte. So imagine then in that case, now we are in zettabyte when we consider the universe 10 power 21, and petabyte was only 10 power 25. Okay, and then it will one day we are expecting that it goes up to Brontobyte. This is the volume of data that is being generated. Complexity, I told you now. In our social media data, there was a variety of data. Always when you say variety, you may have a tendency to say that variety means it is a combination of text and then numerical data. It could be GIF and it could be some some images. It is not like that. When I say variety in big data, it means that the data is structured, unstructured, and semi-structured. Unstructured means you really don't know how to store it and handle it at all. You don't have a proper data structure itself to handle it, okay, to store it. Semi-structured is, as you said, it is not easily queryable. It is not a structured, like you cannot handle it with something like an SQL, not like a structured query. So structured is typical structured type is your SQL type. You have your table formats and all that. Semi-structured would be like, as you said, your JSON files, then RDF files, something like that. Okay, XML files and so on. So that is called as a variety. And when you look at any case like an IoT connected as a smart traffic system, or I have an example of driverless car, everywhere you can see so many type of data that is being generated, which could be a combination of structured, semi-structured, and unstructured. Okay, then speed, velocity, you know how fast the data is being generated. This I've taken from the internet. You can just check again. Every day this figure keeps changing. I took it from a site where the data never sleeps 8.0. In every minute, see, this is a fact. You must understand how things are being handled now. In a minute, this is the amount of data that is, they have established that this is the data being generated. So you can see that in a Facebook, you have 150,000 messages. So messages, as I said, it need not be only some text. Okay. And then if you look at our favorite anything, like you can see Netflix, you can see YouTube, 500 hours of videos being uploaded per minute. And you must understand how much efficient YouTube is, because in spite of that, this is the volume of data that is being uploaded every minute, 24/7, 365 days. In spite of that, it is identifying all of you as an individual. If I log in, the recommendations that comes for me, or the YouTube shorts that comes for me, or the the recommendations in the songs that I want to hear is different. And if you log in, it is different. It is key, in spite of all this large amount of data that is being uploaded. I'm talking about facts. Okay. In spite of that, it is able to identify you as a person, and it is able to tell, it is able to personalize everything, it is able to give recommendations. So imagine how powerful our technology is right now. And this data, maybe if I take the same session next year, I cannot use this chart. This also maybe like 4-5 months back, maybe I've downloaded this. I don't know what is the actual status that YouTube is telling, how much hours of video is being uploaded per minute. Similarly, all these Amazon, everywhere you go to Amazon, it gives you a lot of product recommendations. Okay, so that means they are not piling up this data and sitting idle there. They are also smart enough to handle this. They are also doing analytics every minute. Okay, so this is the challenge with this one I wanted to tell you, which you all know. Another example is how the self-driving car works. So this, we know that this is working now. So if you look at a self-driving car, this is another example of how much data is being generated, what are the different type and velocity, variety of data that is being generated. You look at a car, this is the actual picture which I have taken from there. And then it has got a lot of sensors. You have the GPS there, you have a wheel encoder, you have radars, you have laser there, you have spoilers, which has all these sensors which are attached to it. And a Google car is producing around 1 GB of sensor data per second. 1 GB of sensor data alone per second. That is adding up to 2 petabytes of data per year for a single car. Okay, 2 million GB per car, assuming you ride around 600 hours a year. And please understand, this is called as a typical example of real-time analytics, because all this data is being captured without a fraction of seconds. Instantaneously, it is being captured, and the decisions are taken instantaneously. So based on this, if you look at it, this is the real view of a. Is it visible for you? Are you okay? So see, this is the data. See, what are the types of data? Also, I'll just explain. Look at this car in the middle. Real-time data plus the challenge of this is the data that is generated is real-time. There is no gap in which the data is being generated, and decisions should come split second. Suppose a person is crossing by accidentally, okay, or if it has to identify whether it is just the shadow of a bird flying above, or it is a person that is crossing by, and the data should be collected and decision should be taken in a split second. We cannot say that we have built a deep learning model and then this model takes input from so many places. We have so many parameters. It takes 2 minutes for my GPU to process all this, and then my decision will come and it has to apply the brake after 2 minutes. Is that possible in this case? So the decision should be like how humans do. So there is no gap in the decision. So this is how it actually works. So real-time data plus split second decisions should come. So data is there, learning should happen, and the decision should be there. And when I'm talking about data, it is not simply the sensor data alone. There are three. This is taken from their white paper. Okay. So what they say is that they handle three different types of data. One is technical data, other is the community data, and the personal data. Technical is as you have seen. So it just every second for the car, the environment is like this. So much sensor data is being taken. Community data is related to the like the GPS data. So it's probably going through a particular location. It takes some input from the community. What is the traffic location there, weather there. So that also is being sensed. Then comes the personal data. So this driverless car is replacing a driver in the sense somebody who is sitting in the who's sitting in the car, that like a driver it should understand what is the cooling level, how much AC should I set for the person who is sitting in the front seat or the back, what kind of music my person who is there wants to hear too. So this kind of personal data also is being generated, and personalized comfort is also given to the person who is inside the car. So that data also has to be processed. So this is the challenge that is there with the real. So I'm so happy because this group is a set of students, and these are all, you can go further into, I would say you must go more and understand how this works. You can see the simulation of this, and also you can visit some of the data centers of Google online. It is all free. You can just check how this data, how Google data center works, how many servers they have, all those things. You can just have it as an additional reading, so you will get more idea of what I'm actually trying to talk. And then if you look at basic machine learning algorithms that they use here, as per them, they use regression, they use classification, they have object detection, recognition, they have clustering. All these things are actually being used. That is about some, I've just told you some real examples where these different B's come in. Okay, and then coming to analytics. Now, this is a typical as your other, as maybe you had some sessions on that, like your any machine learning analytics, data analytics, big data analytics also, usually they classify it into 4. Okay, descriptive analytics is there. So that descriptive analytics tells you what happened. It will summarize the past data, what exactly happened for an event to occur. And then diagnostics is, it will just tell you why this particular problem has happened. Then coming to predictive, it will just predict you what will happen in the future. That kind of analytics also happen. Prescriptive is the highest level, I would say, as of now, because it will give you this diagnostics will give you an explainability also. When coming to prescriptive, it tells you what are the problems that will happen in the future, and if it happens, what are the solutions that can be applied to it. That is called as a prescriptive analytics. So basically, data, when I say big data analytics or any data analytics, they can be broadly classified on the type of analytics we can, based on the way in which it works, you can classify it into these 4. Not on many, but basically on the problem that you have and what is expected for you to, if a problem is given to you from a supermarket, somebody has a very, like you have so much of Express Avenue or some different things in Chennai. Here we have Lulu supermarket. They're asking you to tell us, okay, last year the sales went down. What could be the reason? That could be a diagnostic analysis. Okay, or summarize and tell me what are the what was the sales for particular event, for particular product last year. That could be a descriptive analytics. They can tell you next year by this month or in the next 2 months what would be the product that would be sold in. So then that could be a predictive analytics. Okay, tell me why this has gone bad last time. How can we improve the sales of a particular product in the next 2 months? That could be a prescriptive analytics. So these are the examples. Another thing you may be wondering, who is generating big data? Everything, because it's IoT, everything in this world is now generating big data. As of now, I'm talking to you, that is also generating big data. I don't know if this session is being recorded, but if it's being recorded, then you can see that in WebEx, the way I talk, my video, then whatever I'm sharing, all these things are also being generated. You sitting there, you are using your mobile side by side. I know maybe you are attending another class side by side. Maybe you are chatting, you are watching film. Some of you who are online, I understand you will be doing that. So that is also, so you are also generating a lot of data every second. Okay. So nowadays, I cannot really say earlier stages, if you will understand 10 years, 15 years back, you had a source point of data generation. So you will say you have a server, you have some data being generated from some point, all the data is being stored on the server, and then a lot of clients use that. That was kind of a technology. But now everything, even if I have a mobile, that is generating a lot of data. In future, everything that we have Now we know we have smart TV, we have smart refrigerators, smart washing machines, smart gates. So everything, even in the house or the office, is generating data. So model has changed. So this is the model that we have now. Old model, as I said, was few companies are generating data and others were consuming. Now everybody is generating, everybody is consuming data. That is the model what we have now. And what is driving big data is, as we said, as and when high the data, the complexity is high, the data is more, but the value also increases more and more. So if you, as said, if YouTube is not going to analyze the data, then it cannot survive in the market. You understand? So that is the 1 second. So that is the problem here. So, so it is very important. We should have some kind of analytics mechanism to actually deal with big data. Okay, so as in any life cycle of a data, we have 4 A's. We have aggregation of data, analysis of data, application, and acquisition. So the same way, for big data also, this is the normal life cycle. We'll just go specifically into this slide. This I want you to understand. This is the challenge which I was talking about in the beginning. Are you listening? Okay, thank you. Okay, sure. So see, big data value chain. So somebody asks you what is the problem with big data? What is this big deal? You can say, I told you, collection. Now I told, let's see, how do you store the data? Because collection, this is the pipeline, no? Usually you collect the data, then you ingest it, then integrate it, ingest it. I mean, ingest in the sense you will store that data in your own, say you write a query, you have some tools to actually get it into your system, into your databases that you have. Then you will do some pre-processing, discovery and cleansing and all that. Then maybe you have different sources, you go for some integration. Sometimes you would have studied this in your data mining, KDD, knowledge discovery in database and all. This is the same pipeline that I'm showing. You have integration, then you go for some analysis. It could be a statistical analysis or any machine learning analysis that you do. Then you will deliver some pattern out of it, some information from this data. So this is the normal value chain. In this, every point has got challenges. It is big data. Because collection is a problem. Why collection is a problem? The data is structured, semi-structured, unstructured. That is one problem, because you don't know how to store the data. Second thing is the volume is so high. The velocity in which the data is being generated is high. Imagine, as I told you, in a driverless car, how much hardware will you invest on, and how much data should I have in memory, in RAM to process? Because every second I'm going to make decisions. So should I have the entire data of one day and then apply the algorithm? Or should I have some buckets of data, some blocks of data only in memory, in RAM to process? The rest will be there. So what will I do in collection because of the velocity that I have? Okay, and should I have a mechanism to filter it out in the beginning itself, or should I collect all the junk data also? So like that, every week is a problem in the collection part. Then coming to ingestion again, loading this vast amounts of data onto a single data store, is it possible? Because you have to have a kind of distributed mechanism to store the data, because this data is being, how do I store it? As I said, whether it should be on a normal hard disk in different file formats, how do I really put it on my hardware? So that is how do I ingest. Because of these challenges, that is a problem. Then discovering and cleaning, what is the format that I can use? You have learned some pre-processing, say you will find out missing values, that is all fine. But when it is the different challenges are there, when the velocity is too high, what kind of a cleaning should I take? What kind of summary statistics can I take? Can I, if I have to create even a box plot, every second the data is being generated, the data distribution is keeps on generating. How do I identify as an outlier? Now I will say it's an outlier, but after 5 hours, the data that I called as an outlier would be the prominent data there. So these are all problems when we apply the typical pre-processing, cleansing, discovery, and all that. Integration again, you know, we have this entity resolution. If you want to see applying, the decision has to come as a joint decision. It has got different sensors. It has to take inputs from different sensors, but the decision is a single decision, whether to apply the brake or not, or whether to release this product or not. So in that case, it has to have an entity resolution problem. No, it has to identify a entity, IR problem. So how do I fuse this data? How do I link this data? Like we know that in a typical database, RDBMS, you know that you have a key which you will call it as a master key. Then you have different tables connected to it. You have a foreign key. But here, how many will you have? And some of you would have studied in data warehouse. You have even gone for a data structure. Any of you have learned data warehouse? And can you tell me what is the data structure you use for storing data there? Higher level of RDBMS, different dimensions. What do you call that as? In a data warehouse, usually. Have you heard about data cubes? Data cubes is another representation of data when you want to handle large dimensions of data. Okay, are you listening? I can only see the screen, so I will keep asking this. Okay, fine. So that is another problem that we have. So now we have moved on to as we said, from data cube was there. Now we call it as data lake because the way in which the information is being generated. Then coming to analysis. You have studied, I don't know what class you had last day. Maybe you had a class on classification. Maybe you know how to do KNN on a problem. Then you have some K-means. Then imagine if the number of records are not going to be, if you have 1 TB of data and if they ask you to apply a KNN, how much time will it take? Leave your deep learning mechanisms which can do faster. That is fine. That takes sometimes, building a deep learning model, LSTM or a YOLO V3, it may take time. But if you apply simple machine learning with the number of instances, say around 1 billion instances of data, how much time will it take? So that again, I would say, whatever you're even calculating a statistical information about it, creating a box plot, will take a lot of time because of the volume, velocity, variety, and what type of analytics will you apply if you are going to have a unstructured data. So that is the analysis part. There are challenges, and delivery also. Maximum, how much can you plot on a visualization tool that is going to be, that is like a scatter plot or a histogram. So you need to have, see, we have aligned the workshop this way where little bit you will learn about all these things. This is not a big data analytics workshop, so you will only know the visualizations that can be applied for machine learning. But in the next level, when you study, please go through visualization techniques that are specifically given to handle big data also. Because of the variety, velocity problems, it is not easily, you cannot use the typical visualization techniques that are available, like your scatter plot, block plot, and things like that. Okay, or your histograms. So you will have other tools that are available for handling visualizations in big data also. So sometimes it will be like a parallelogram, a dendrogram, sometimes up to some extent. So heat maps are there, like that different plots are there. And for GIS, you have a lot of other tools which are already available. So like that, you can just look in what are the techniques. There are a lot of challenges in the delivery, that is in the visualization technique. So the challenges being addressed also, but still it is, this is an open problem still. You need a standardized approach at each step. If you are planning to do a research, if any research scholars are there, you can pick up any one of this area and then you can start digging deeper, because everywhere there is an open problem, research problem available. Now I've told you all this, and what is the difference? So between a normal data analysis setup that you have, like you have a Python library, you have a GPU to access your DPU, your deep learning algorithms. Other than that, when we talk about a big data, there are different tech, provided by different vendors. Okay. Also, every company, like if Google handles it, YouTube handles it, Amazon handles it, that means they have their own technology stack. So if you look at a big data technology stack in a nutshell, I can say that there are different layers that are given to it. One thing is there is you can see there is a data layer. Okay, data processing layer is there. Then you have this data ingestion layer, data presentation layer. Then you have the complete orchestration of this cluster that you have created, big data system that you have created. Okay, that is taken care by some orchestration software. That is like an operation, scheduling of the cluster, assigning jobs, all that will be taken care by another set of tools, and security and governance, another set of tools will be there. So you will have a combination of all this. Say, for example, we have in CUSAT, Cochin University, we have a big data Hardwood cluster that is being set up. So we have, initially we had it from Hot and Dataworks platform. Now it is given to Cloudera. So CDH is the platform that we actually have installed for our working. So if you look at our platform, you may see that you will have a layer of all this present there. Similarly, if you go to take a solution of, I think I have few slides. Maybe I will have few slides on that. I can just show you. So you can just check what are the different technology stacks. You will not get a standard diagram like your OSI network layer to say that this is the big data technology stack. It's not like that. It is just one instance which I'm giving you to give you an idea, because every company uses different tools for handling different components of big data, layers of big data. So here, if you see the data layer, this is the bottom layer where you would have heard about this HDFS or Hadoop. Hadoop is a framework, distributed framework, which is an open framework given by Apache. You can also browse further on that. They have come out with Hadoop was initially what was come out, and HDFS is a distributed file system, which is called as Hadoop distributed file system. This is used to handle big data. So this can up to some extent handle unstructured data also. Okay, and then you have S3, which is a bucket which is given by Amazon. Microsoft Azure has their own things, and then you have IBM, which they have their own parallel file systems. So like that, for handling the data, there will be a separate mechanism. There will be a separate set of tools and technologies that have come out. Then coming to data processing, as I told you, and when I said Hadoop and Apache, please go to Apache website and see that after Hadoop, then there are other things which have come out. I think there's some slides I'll talk about the Spark and other things. Coming to data processing layer, you will have a n number of tools that are available. Okay, so when you look at your check for big data tools, you can see all these names coming up again and again. So you must understand, you will have, if you have to have a solution at hand, you will have a vertical session of this. Say, for example, I will have HDFS as to store my, then I will use Hive queries. Hive is another structured query language. It can partially help us with the SQL part. Or I will have a NoSQL HBase, or I may have a Spark installed. So one HDFS, Spark, Kafka, and then scheduler, maybe I get a solution. So like that, one vertical, you can actually get a solution. You can just install and you can have a complete solution. That entire pipeline challenges can be handled up to some extent. So you have to choose what tool you want, what is the problem you have. Once you are into a company who's already doing this, then they will have their own set of tools to handle. They will have their own verticals here. Okay, so coming to this data processing layer, you can see that you have scripting. For scripting alone, you have something which is called as pig here. Then Hive queries, like a structured, if you want to handle structured large volume of data, you have Hive queries. Hive is there. Then for NoSQL type, NoSQL, I'm coming to it, you have HBase. Then you have for search related Apache Soar is there. Then in-memory computing, Veloz, you want to deal with some kind of machine learning. Say you want to go for streaming data, maybe you can use the Spark. And then if you want only machine learning, and that has to be done in Hadoop only, then this Mahout can be used. Mahout is a machine learning library that comes along with Hadoop. Okay, so that is that. So you can choose between this. Coming to data ingestion layer, Kafka is very important. It has its own architecture. This is used, suppose you have a streaming data, you want to actually publish, subscribe, or broker architectures are there. You can just, it will help you like a, it will be like a gateway for you to pull streaming data and ingest it into your data layer. That is a use of the Scoop. This is given, this is Scoop actually given here, or Kafka tools are there. Then data presentation, as I said, for visualization, lot of Geo for Neo4j are there for network type. You have Kibana, so many are there. Then the whole thing is to be managed as one. You may have to have, and also see, this data is distributed. I said the data is going to be stored in a distributed manner. So then it is entirely a distributed framework that you are using. There should be a data node. There should be a name node. It's like client and server in a distributed cluster. You call it as a name node, which is like a server. You will have a lot of data nodes, and different blocks of data will be distributed and stored in the data node. Like that, it keeps on going. So all this will be handled by the other layer of software, which is the manager of the cluster manager software. That is, example is Apache's Zookeeper or Apache's Ambari or Zoocy, and there may be Cloudera, there may be Hortonworks, there may be so many. Okay, so I'm just giving an overview. This is how the test. So when you just check into the web asking for big data technologies or tools, software, you may see a combination of all this. You must understand that for each task, there are a set of tools that are available, and there are updated versions. You can still search for more things. Are you listening? Okay. Your S is like an encouragement for me. Otherwise, I will not think that nobody is here. Okay. So now coming to this, this is what I've told you about the different bits. So now each one is explained a little bit. I think you can also read through later. I can share the PPT. So when you say Hadoop distributed file system, it's called in a, as I told you. See, if you can still listen, HDFS is it is a distributed framework that is given, and it can handle unstructured data also. When I'm talking about this Hadoop has got different components. One is it has an ecosystem where one component is HDFS for storing the file. Other is, you can also note it down, and later we will, when you have a session on big data, you will understand the programming paradigm that was used along with HDFS by Hadoop was called as Mapreduce Programming. So it was like a different multi-threaded programming that you write in Java. You will be able to write map task and reduce task, and your files, your data will be distributed automatically as 64 MB blocks of data. It will be stored in a distributed fashion. And when you write a MapReduce code, this task can run parallelly on these blocks of data. That's how this HDFS used to work. It is very famous distributed framework. It became very famous with MapReduce became very famous when once this Google started using it. But it is an older concept, but still it became very famous with after Google started using it also. Then you have other storage services, as I told you. S3 is a bucket, storage bucket given by Amazon. So then IBM has its own parallel file systems that you can say. MapReduce, I told you, this is a framework for writing distributed processing. You can't write a typical program to handle this different blocks of data. You have to use some kind of a distributed framework for writing programs. So it's all easy. Only thing is you must understand how what is the construct, like how it works, how to write a map task, how to write a reduce task, and then you can just actually the model that happens in distributed here is the beauty of that is that here usually, unlike you write a code and you fetch the data, now it is different. The data will be distributed and the code moves on to the data and then executes and comes back. That is how it works in a MapReduce framework in a HDFS setup. Okay, then if you want to write some scripts, you can use what is called as an Apache Pig is there, and Pig Latin is a scripting language that can actually convert this MapReduce and then write it and execute it into a. So each companies come out with their own tools for they create their own tools, for easiness, and then later they give it to make it as open source and given to others to use it also. Okay, so that's why there are many tools here, because you can see Hive, which works like an SQL like language on, and that will help you. It will look into this. You have a query, it can be converted to MapReduce jobs. So that provision is given by this Hive QL. Then Apache HBase is there. That is again an NoSQL database. I think I have few slides on NoSQL. I tell you what is the meaning of this NoSQL. Then Cassandra is another one. Storm is there. So you can just go through all these things. This is very important. One slide which I will take little time. See, as we said, this Apache or distributed framework, that if at all you people want to try with big data, if you are moving on to this after learning your machine learning basics and all that, see, you can try with this Apache Spark. It is easily available. You can go to Apache website and you can download this Apache Spark on a standalone system. It is a cluster management framework, distributed framework as per. And Hadoop is not much used after the Spark because Spark is more faster and easier also. And it has Hadoop was batch oriented, but here Spark is not batch oriented, and it has got in-memory computations. So it is always easier. So Spark comes out with a solution by itself. Spark has a new type of a yarn. I don't know if you have heard about. It is called as yet another resource negotiator. This is the scheduling algorithm, schedulers that it is using. Yarn is there. Then Spark Core, it allows you to program. There are programming with RDDs and data frames. Then you have different 4 components. Like for working with structured query, it has got its own libraries. APIs are there. For streaming, you have Spark D streams that can help you to do that. mlib is a machine learning library. So if you have a large amount of data, if you have installed Spark, you go through, it is easy. And you can try on your laptop also, or you can set up distributed, like you have 4 or 5 systems, you can try setting up Spark, connecting all these 4 desktops, something. So what you can do is you can just use the Spark to work on, actually do some hands-on big data. Okay, so that is the advantage. I'm just giving you an overview. You can just, there are a lot of tutorials available in Apache Spark website itself to learn about Spark. But you can see after Spark also few more has come, which is called as Flink and Fume, I think. Two more are there. Flink is totally for real-time analytics, for handling streaming data. Okay, before that you had this Apache Mahout. I think you just know about it, but you will not be using much this Mahout there. Mahout is the, any of you know what is the meaning of Mahout? Or why it is connected? What is this symbol which is given there? See, Hadoop was it was a initially very famous framework, still being used. And if you install Spark, still you can work with Hadoop. Hadoop was very famous in the sense, this you can see this whenever people talk about big data, they show this, that one elephant is there. It is a toy elephant of the person who duck cutting, who has actually created, developed this Hadoop. And Mahout means taming an elephant tamer. Very good. Avani, you have written there, na? A person who tames an elephant. Very good. So here what is the meaning is, if you have a large amount of data which is considered as an elephant, and you need some machine learning algorithms to tame that data, to bring out some inference, some task you want to perform on it, some task you want to perform on the data, and you want to come out with some inference. So that is the meaning of this Mahout here. That is why they have called this machine learning library Hadoop as Mahout. Okay, but to be very honest, we are not using Mahout much nowadays. If at all I have a problem, if I want to try out some machine learning, I will be using the Spark framework. Okay, but you can also try Hadoop also. Installation is also a little tougher when compared to Spark. Now, as we were talking about NoSQL. Now, before I give an enter, NoSQL, what is the full form? Not SQL. Somebody can type. There are some people who interact. What do you mean by NoSQL? Any one keyword, one word you type. Not only. Very good. So NoSQL means not only SQL. Means SQL is still prominent. Okay, but still we are not able to work only with SQL. We are not able to work. We are only with SQL. Only with SQL. So we have different. We have to have. There are different. Not only SQL type of databases that have come, but we must understand that at some point of time we may integrate it with some. As I told you earlier, you can use a script. Hive queries, which can actually convert. That's an intermediate tool which will help you to write queries or convert these queries into Mapreduce tasks and so on. That also happens. That is called as NoSQL databases. So nowadays, even in our subjects, we talk about emerging databases or advanced databases. We have to learn about the not only SQL type. So in that, again, there are 4 types of not only SQL that are coming in. One is some document stores. That is, there are some tools which can help you. Even HDFS helps in that. There are some tools which helps you to store the document type and then apply operations on the because a lot of NLP text documents are to be analyzed. Other one is, I think I have few on that. Then graph databases are there. Different graph databases for the sake of like giraffe. So many are there which will help you to work with only graphs. Okay. Then key value. This is very famous and it was already there. This key value store pairs are there. That is, you store that like you said in your CSV. Similarly, here the entire data will be stored only as a key and a value. So the key and the value is the entire. Suppose I am storing, say, one library full of books. So in that case, simply I am just saying, so in that case, my key would be content of the book. So like that, anything can be converted into a key value, and this Mapreduce program. Many programming paradigms use this key value pairs. Okay, and then columnar databases. Rather than having your typical SQL type row and column, you may have only an expansion of columns, and you have columnar databases available. Then these things I will skip again. You can go through because too many things you will get confused. These are all other tools that are available for the data ingestion layer. Okay, very important for streaming. You can use Kafka as we have said. Flume is also available. That is also large amounts of streaming data it can handle. Then Scoop is another tool designed to transfer between. This is very important. When you want to, this is what I said, like your, it is an intermediate one. So you have written your data, relational databases and Hadoop if you want to transfer the data. The Scoop can be used in between. So it is it can convert between these two types of files. Types of files means you will understand. Actually, it was initially developed for working with mainframes when they were using this Hadoop Mapreduce program. So to export and import back, you needed this tool. So it was developed and then it was given as open source. And this I told you, I think Ambari is for the overall orchestration to manage the core component services, Hadoop services, cluster management, web interfaces. Suppose you want to see how many blocks of data is distributed where and how many data nodes are working now. What is the status of my name node? What scheduling it is? I have my algorithms have, my OS has used. All those things can be visualized if you have they provide with web interfaces also. So you can just manage the whole full horizontal verticals with the help of these tools. Okay, Uzi, then Zookeepers and all are there. Now I've told you about what are the challenges of big data, what is big data, what are the tools that are generally available, how many layers this technology stack will be, and all that. I think we'll move on to a little bit. So you can see that this is what I think another thing I've given. So generally you can see Spark, Flink, and Storm is Apache's typical solutions, open source solutions. So they always come like this: database, streams, resource management, execution engine. And I've taken a table and pasted it here. You can see that these are the tools that have come out. Initially, what they had is called as Hadoop. So this has some limitations, like it was only batch processing. You submit the job, then you cannot interact in between. Okay, so it was not interactive. Then came a software with a directed acyclic graphs. Phase one software, one tool, they came out with another framework. Now the most important or most easy, at least from my point of view, is Spark. You can try with Spark. Okay, there is something missing here is I have taken an older table. Recently, Spark also supports data frames that you use in Python. So it is more easier now. Initially, it was only RDDs, but now it uses also data frames. So then comes Flink. Suppose you know that you want to really work only with the streaming data and you want to perform real-time analytics. Then you can try installing Flink and then you can start working with Flink. I think there is one more which has come up, Flume, or you can just check that also in the Apache workflow. Okay. So this is very important for a beginner and for a person who want to try out with big data. You can use any of these tools because they are open source. Now, as of now, I've told you all these things. I want to connect you a little bit with I can stop also after 5-10 minutes. I'll just tell you. Now one important thing I want to tell you. We are talking about machine learning. Now, this workshop is on data science using Python. Data science means, again, most of the classes are on machine learning techniques that you have. So understand that when it comes to big data, are you listening? I need some energy in between, no? Some yes or no. Avani, good student. Yes, very good. Avani, where are you? You're studying somewhere, Avani? Swanandu. Like in a network, you have focal nodes, no? Like in an online session, you will have some focal nodes here, some important people who will keep talking. Otherwise, just the screen and me sitting in my room in some part of in Kerala and then talking. St. Peter's College, what is that? St. Peter's? Avani, I'm a student. Okay, fair.
Yes, ma'am. It's St. Peter's College.
Oh, very good. Here only. Shivanandu. And what about Avani? Mahout answered. She answered, I think. Where you're a student? Where? In CUSAT? Why no reply? Okay, now listen. Then coming to ML challenges. I think this much you have understood. I am studying KMCT Engineering College. KMCT is where? KMCT. Calicut. Okay, good, good. Okay. So now listen, so coming to machine learning challenges. See, after you learn all your basics, Python, data science, typical machine learning algorithms, you can move on to what are the different types of algorithms that are available to handle big data also. Okay. So because of this challenges, volume, velocity, variety, there are a class of algorithms, set of algorithms that have come up with big data. So now this is the critical issue since this when I pasted it is not very clear here. Critical issues is learning from large scale of data because of the volume, learning from different types of data because of the variety. There is a problem. High speed streaming, you know, now it is velocity. Then uncertainty, veracity. Then value also is important because density and different diversity is there. So how do I get from low value data? Because every data may not be meaningful to me also. So these challenges are addressed, and these are the specific problems. Okay, this is at least in the research point of view. If you can see that there are algorithms to solve all these problems. When I say volume, the problems are processing performance. I told you, I think I have slides on that. When you have the number of samples are very high, you know, at least most of the algorithms are based on the complexity are based on the number of samples, say for example. Okay, or then the time it takes will be very high. Coming to modularity, again, we know that how much of it's called as curse of modularity. That means some algorithms assume that the whole data that you want to perform will be in the memory. But in the case of large amount of data, that is not possible. That is why when you see that the GPUs come with built-in high RAMs, you have a technology which you can note it down and read, which is called as in-memory computing. Spark uses in-memory computing because it splits up the data and keeps that in memory, like in the RAM. So that is called as modularity because sometimes, as I told you, like you cannot store the whole data and then rebuild the model every time. There should be different architectures which can actually handle this curse of modularity. There are architectures for streaming that also you can note down, no time here. Lambda architecture, Kappa architecture and all, which you can go through. Then class imbalances, sometimes you will have, you may have, it's a binary classification, but you may have lot of samples only in one type of a class. And other classes you have very little. So you will be able to make your machine learning learn. There will be a class imbalance. You have algorithms to actually handle class imbalancing. Cause of dimensionality is the number of parameters that you have. So when I tell you it is an iris data set, you know there are only 4 features. When I say it's a student data set, maybe 10 features. Suppose if it is going to be a real-time data like an healthcare data, you want to analyze why this disease is being spread or what is the cause that a person has got a cancer or something. You know the number of parameters would be, you will take, at least say, you will have data which hereditary. So what is the history of mother, history of father, history of somebody, and then blood level information. So many blood tests they take all that. Then genetic level, gene test sometimes they do, then gene level information. Then they will look at the demography, you belong to this place. Then they look at the diet, lifestyle. Okay, then they look at ECG, EEG. Then they look at that, this imagine, all this has to be tabulated. Then you say this person has this amount of cancer. Similarly, you have 100 samples sometimes, or a particular type of cancer, maybe you will have only 5 records, only 5 patients in a year. But the number of parameters that you have, will be around 1,000 parameters. So then how do I train the algorithm? And that is a problem also. Lot of features, okay? So you have to think about that. Feature engineering is how do I filter out important features? So you will learn about this PCA and other things. So then non-linearity. You cannot have always, this because of this non-linearity, you have a variance bias problem. Then you have something which is called Bonferroni principle. All these you can learn later exactly what it is. Some slides are coming in. These are problems pertaining to because of large volume. Similarly, pertaining to velocity, data availability, concept drift is very important thing. As I told you, the concepts itself will change. As of now, for me, one data is very important. My algorithm, clustering algorithm, will say it is an outlier. After few windows, after few data being generated, you will understand that there is a drift in the distribution, and this data becomes the actual data. They are no more outliers. So that then again, sometimes you can see that once you start building the model, you may have 3 or 4 labels, classes, but new class may generate in, if it is a product information. You can see that you built a software which say that there are four types of products there. Okay, one is like healthcare product, other is going to be what to say, some cosmetics like that. You sometimes a new product itself can be generated. So these are some things which are called as concept evolution, feature evolution, drifts and so on. So like that, lot of challenges are there because of velocity. You must have a machine learning algorithm to actually handle all this. Coming to variety, as we said, there are a lot of dirty and noisy data that you have to look at. Data heterogeneity is a problem. So what algorithm? Entity identification problem. How do I actually identify that this entity, one sensor gives me some input, other gives me some input, but all about one single entity. So how do I integrate it? How do I make it to integrate and make it to give a single solution, apply it for a single solution? That is a problem with variety. And veracity, you know, uncertainty, dirty, noise. Now you have seen about a lot of fake news detection. A lot of things are coming out of social media data also. So how do I actually identify my veracity? Means data in doubt. So how do I, what algorithms can I apply to handle all these issues? These are the basic challenges with machine learning algorithms when we are handling big data. This I will skip little bit. One or two, I've told you all this. This is one example. I know you have studied SVM, for example. You can see that the time complexity is order of m cubed, and m is the number of training samples. So imagine if the m increases, what would be the complexity? Class imbalance, I told you, dimensionality, feature reduction. The Gonfroni principle is a typical problem, statistical dealt with statistic. You can always see that. See, sometimes, you know, certain things are, there is a bias in the decisions that is being made. So you can see that certain amount of data, what we have, you know, always it has a bias towards finding out a certain event. Actually, whether this event has happened or it is because of the data that we have collected, this event has happened. This is actually a curing that has to be done, which is called as a Gonfroni principle. For that, he has come out with a solution that you can later see. Another important concept, I think it will be dealt in your machine learning data science classes somewhere, which is called as this variance and bias. This you can note it down. It's a very important concept. See, sometimes, you know, this variance is the see, I don't know how far you learned your machine learning, but you have a target function, okay, and then suppose this this target function estimates something. How much amount of variance actually decides how much amount that the estimate of the target function will change. I'm using one data set. What is the variance? If a different data set is used, what would be the how much amount it will, the estimate will vary. Estimate of the target function will vary. That is called as a variance. So your algorithm should not change too much from one training data set to another training data set. That is important. You must always write an algorithm which can handle, which should have low variance. So what is necessary is a balanced one, the low variance and a low bias. Similarly, because if you are training it with a high variance, it will actually give you overfit. And when you introduce a new data for inference, when you're bringing in a new data, it will not predict your performance will be poor. It will not give you the correct output. So that is called as overfitting. Because of coming to underfit, it is that is bias. Bias are you maybe you had a class on regression, so you have simplifying assumptions. The regression is example with a high bias. You have some, when you're building a model, you have some simplifying assumptions, and the target functions are easy to learn. So it will not handle variance much. It will be biased to what it is there, and based on that, these assumptions, the target functions are built. So in that case, what will happen? You know, they have a lower predictive performance on complex problems. So that is why it cannot handle non-linearity also. So you must always, this is a challenge in machine learning. When you are building up a good machine learning model, should always be a balanced one. It should preferable is always low bias, low variance. Therefore, we don't have underfitting problem or overfitting problem. So this also applies to big data. I'll just skip certain things. It may go. So this much you understand that now this is the status. Okay, these are the. Are you listening? One more is. Okay, see, this is the status now. There are a lot of challenges. There are a lot of solutions also. Okay, for us to so just understand this. So if you see uh, for handling this data, there are manipulations that are done with the machine learning algorithms, or new machine learning paradigms have come. These are some of the solutions that are right now available. So sometimes we have made some manipulations at the data level, or at the processing level, or at the algorithm level. Okay, and sometimes what we have done, there are new, this is very important, because throughout the session you will be learning, throughout this 5 days you will learn about supervised learning, unsupervised learning, and semi-supervised, I don't know, sometimes semi-supervised learning, but and reinforcement learning, sometimes people can say. But you can see that there are other learning methods which are pertaining to especially big data, to handle big data challenges, which are called as, like, deep learning can handle up to some feature engineering. See, this tick mark indicates that deep learning is capable of handling feature learning and non-linearity. And when it comes to variety, data heterogeneity, up to some extent, deep learning can. Similarly, very important learning is there, which is called as online learning. That is a new type of learning that has come in. Not very new, but still that can help you to handle lot of velocity problems. Online learning, learning on the go. So you can see that data, this velocity, I told you some challenges are there that can. So if you have a typical problem, you understand that this machine learning is a big data, streaming data, then you can go for using some, instead of a supervised, unsupervised, you can go for an online learning strategy, which can be applied to classification, clustering, everywhere. Then you have something called as local learning, which can handle certain challenges, transfer learning, lifelong learning, ensemble learning, and the list goes on. Okay, I've only taken a table from some paper which I have mentioned here, but there are other few more learning algorithms which are you have active learning. So many are there which comes in with this. So you must understand this is a state of the art as of now. Challenges are there, but there are a lot of modifications done on the machine learning or analytics part to handle these challenges also. I will skip this. So you can see, as I told, this is our initial thing which I started. Data pre-processing, manipulations can be made. In transformation, some manipulation, storage, some manipulation, analysis part also, some manipulations can be made to handle this big data. I'm just skipping this. This I can explain, but it later maybe we'll have another class on big data. So this is one solution, as we said, big data. These are the challenges, and sorry, these are the challenges. These are some learning algorithms, and what are the solutions that these algorithms provide is given here. And these are the technologies that are enabling technologies that will help you to run these algorithms. So if you look at it, the challenges are there because of these technologies. You are able to handle. You see one important slide, previous slide, which is skipped. You can see that you have, for handling this big data, technology wise, you have multi-core CPUs, you have many core CPUs, you have something which is very important called as field programmable gate arrays, and very famous GPUs are there. So they help us for parallel and distributed computations. So when you write an algorithm, like if you're writing a deep learning algorithm, it can handle the variety, feature engineering, those concepts of big data. If you want it to run faster, then you will use a GPU. Okay, and your coding will be, you will write it as if it can be executed on a distributed mode, and then you can use this GPU, so that the entire pipeline is through, because the algorithm has the capacity, the algorithm manipulations has already been made, and it is supported by some enabling technologies to execute faster. So that's how all these companies are handling big data. So I'm just skipping this. I've told you a few of this. Please go through. So some technologies you can see, there are a lot of, as I said, distributed technologies are there. Parallel computing are there. There is a difference between that. Hadoop kind of technologies have come in. Cloud computing is another important technology that goes hand in hand with big data. All of you know what is cloud computing, I assume. You can't, it helps you to, always it is not possible for us to invest on hardware or any infrastructure. So you can easily move on to cloud also. As I said, this Amazon S3 and all, many cloud providers are there. So that also helps in handling big data easier. Many of the clients here, like you talk to some companies, they say that they are doing big data projects. Maybe yesterday also Mr. Jitu would have explained to you about that. So they have different projects at TCS that they do for big data. But if you look at the infrastructure, they work on cloud mostly. So either the infrastructure is provided by the client themselves, or they take some big data cloud infrastructures. So not always that people build higher HPCs or Hadoop clusters at their premise. They also use cloud computing. When it comes to research purpose or experimenting with some scheduling algorithms or on your own some algorithms like security features and all, maybe you'll have to try at least a low cost infrastructure to work on certain research kind of problems. If you're working on developing newer scheduling algorithms like in Yarn, then you may need your own infrastructure built at your premises to test also. So this is also one point you have to note down. Some technologies, distributed parallel cloud computing, distributed frameworks, then note down this also, that is in-memory technology. This is very important technology that is made faster processing. So because that is also important. Then a lot of problems are still pending. These are the open issues. I am given time up to 11 o'clock, so I'll just rush through. So many problems are still open. How, as I said, challenges are still open. Solutions are there, but still problems are still open. Applications, you know, I have told you many applications right now. Everywhere you can see big data, okay, simple. Telecom, trading, search, manufacturing, hospital, smart healthcare, homeland security, IoT, wherever. Then risk also, every time there are risks. Cost is going to, you can't keep investing on hardware, software. Okay, sources also is very high. Everything is generating data. So some legal regulation, self-regulation should be there. You need right people. There is a lot of job opportunity in data scientists. Then it is a big deal because machine learning, computer power, database decisions, deluge, all this is going to be the future. And a lot of people have invested already. You can see that federal research, 1 billion. So many people are on to it already. So if you build yourself with a good set of tools, you will get a lot of jobs, 100%. So everywhere there is something called an oncology advisor, then recommendations, Google, Netflix, everyone needs you if you know how to do this thing. Then vendors, you can see IBM is there, Amazon, MS, Google, so many are there. Okay, so future 2025, as I told you, I'm not giving explanation on this. If you can understand, you can read. We assume that 175 zettabyte would be our actual data, digital universe. That's the amount of data. It is a statistics given, and I've given the data source. You can read through. Future, so many are there. Okay, so it's as I given, machine learning will continue. Data science and CDOs will be in high demand. You people are at least listening to this. You have opted for this workshop. It's a good right path that you have chosen because there are a lot of opportunities coming in. And privacy, you will have to look in. Fast data, actionable data is another thing. Explainable AI is coming up. So like that. So these are the references. Few references I would have by mistake given there, then and there. This is all. You have something to ask? I think I've.
Okay, ma'am. So thank you so much.
Thank you.